Dear students, in this video I am going to discuss about some concepts from the chapter circles. These are very important for JEE point of view. Just concepts and formulas like that, shortcut formulas like that. Actually, what is the definition of this circle? Circle is nothing but the locus of the point in a plane, which is a constant distance from the fixed point. Suppose it is the fixed point and r is the constant distance, then so many points located r units distance from this fixed point like this. Then this locus is called, locus is nothing but path of the points. All these points forms a one path, that path is called the locus. Here that locus is the circle. If you want to find the equation of the circle having the center at h comma k and the radius r, then take any one of the point along the circle is some x comma y. Then Cp is equals to r. Cp square is equal to r square. That means x minus h whole square plus y minus k whole square is equals to r square. So it represents equation of the circle having the centered at the h comma k and the radius is r. This is the basic formula. If you know center and radius, then we can use this formula. Suppose if the center is some 0 comma 0, the circle having the center at 0 comma 0 and the radius is r. In this case, equation of the circle is x square plus y square is equal to r square. H comma k values are 0 comma 0. So this form of the circle is called the standard form. Whenever if you want take the equation of the circle, generally you can take a standard form. For solving theoretical problems, you can take a circle equation as x square plus y square equal to r square. This is the equation of the circle whose center is 0 comma 0 and the radius is r. Suppose the radius of this circle is 1 unit, then in that case the circle is called a unit circle. If the radius is 0, that circle is called a point circle. So what is meant by point circle? The circle whose center is something but radius will be 0. So what is suppose if you take point, this is called a circle. This type of circle is called point circle. Suppose the coordinates of this point is 1 comma 2, then the equation of this point or this point circle is x minus 1 whole square plus y minus 2 whole square is equals to 0. X minus 1 whole square plus y minus 2 whole square equal to 0 represents which one? A circle, and also particularly you can say that is the point circle. What is the center of that circle? Center of that circle is 1 comma 2 and the radius will be 0. So actually by observation, this is the square of one term, this is the square of the other term. These two are clearly positive terms. Sum of two positive terms is 0 means then both are equals to 0. So from this we will get x minus 1 equal to 0, y minus 2 equal to 0. So x is equal to 1, y equal to 2. It represents a point, also known as point circle. So if the radius is 0, that circle is called a point circle. Next, the general form of the circle. This is also one of the important form. X square plus y square plus 2gx plus 2fy plus c equal to 0. It represents equation of the circle whose center is minus g comma minus f and the radius is root of g square plus f square minus c. After making this expression into sum of the two perfect squares, we will get a circle equation form whose center is minus g comma minus f and radius is root of g square plus f square minus c. So if the circle is a real circle, for real circle the condition is g square plus f square minus c should be greater than or equals to 0. For imaginary circle, what is the condition? Radius will be imaginary. That means g square plus f square minus c is less than 0. If this inside value is negative, then we will get imaginary value. In that case, that circle is called imaginary circle. This condition also important. If the circle is imaginary, what is the condition is g square plus f square minus c value less than 0. So this is called the general form of the circle. X square plus y square plus 2gx plus 2fy plus c equal to 0 is called the general form. In general form, what is the observation? Coefficient of x square and coefficient of y square must be equal and equal to the 1. In this case only, you can find the center and radius. In this case, what is the center? Minus z comma minus f, and radius is this one. Sometimes here 2x square plus 2y square will be given. In that case, immediately we can dividing by 2. Always we can make the circle equation into general form. General form is nothing but x square and y square coefficients are equals to 1. In that case, center is minus z comma minus f, and radius is root of g square plus f square minus c. Here one concept, every second degree non-homogeneous equation, that means ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. This is a general form. This is called the second degree non-homogeneous equation. Second degree non-homogeneous equation represents different types of curves, either pair of straight lines or circle or parabola or hyperbola or ellipse, whatever it may be. Depending upon the conditions, we can say that the nature of that second degree curve. If it represents a pair of the lines, what is the condition? Already we know in the first year, delta equal to 0, and some other conditions are there. H square is greater than or equal to AB, G square is greater than or equal to AC, F square is greater than or equal to BC. If the second degree equation represents all these conditions, then we can say that it represents a pair of straight lines. When it represents a circle, then delta is not equals to 0. Delta is not equal to 0, and the coefficient of x square equal to coefficient of y square. Coefficient of x square is equals to coefficient of y square, and circle equation not containing the xy term, that means coefficient of xy equal to 0. Circle equation always, in the circle equation xy term will be absent always. So for eliminating this term, xy coefficient equal to 0. That means here a equal to b and h value is equal to 0. Very, very important. If any second degree equation represents a circle, generally we can take the this one, coefficient of x square equal to coefficient of y square, and the coefficient of xy equal to 0. That means h is equal to 0. Now, sometimes if you want circle equation of the circle passing through the points 0, 0, a 0, 0, b. We can remember as a formula. Whenever the points, actually, if three non-collinear points through three non-collinear points, how many circles are drawn means only one circle is exist. So if you want one circle equation, 3 points are required because of x square plus y square plus 2gx plus 2fy plus c equal to 0. Actually, it represents a circle. For finding the circle equation, here 3 unknowns are there, G, F, C. For finding 3 unknowns, 3 geometrical conditions are required. Either 3 points or 2 points, some other condition like that. So that for finding the G of C, then 3 geometrical conditions are required. You can remember that one. Anywhere, if you want to find the circle equation, compulsory 3 conditions, or sometimes center, radius, that is okay, that is different. If you want to write in this one, 3 conditions. Now, this is one shortcut formula. The equation of the circle passing through 0, 0, a 0, 0, b. That is x square plus y square minus ax minus by equal to 0. So here, what are the points? One is the origin, and the second one is the a comma 0. A comma 0 lies on the x-axis, and the third point is 0 comma b lies on the y-axis. When joining these 3 points, we will get a right angle triangle. Then what is the equation of the circle passing through these 3 points meanings? Direct formula is x square plus y square minus ax minus by equal to 0. So 0, 0, a 0, 0, b. How will get this one? This is a right angle triangle. Then we will get center. If the circumcircle of the right angle triangle means this hypotenuse becomes the diameter of the circle, and the middle points becomes the center. We will get center, and the radius is upright. Radius is this distance becomes the diameter. Half of that length is the radius. By using center and radius formula, we will get this one. Or otherwise, we can take the general circle. X square plus y square plus 2gx plus 2fy plus c equal to 0. And what are the three conditions? If passing through 0, 0, a0, 0, b. Substituting one by one, we will get g value, f value, c value. Always c value is 0. When the circle is passing through origin means constant term value is 0. Directly we can take c value 0. When substituting these points, you will get g value and f value. So this is one shortcut formula, 0, 0, a0, 0, b. Then directly we can write circle equation as x square plus y square minus ax minus by equal to 0. And also this is what is a? A is the intercept, the length of the intercept made by the circle on the x-axis. This length is called the intercept made by the circle on x-axis. And this length is b, that is the intercept made by the circle on y-axis. So if you know x-intercept and y-intercept, then circle equation is this one, x square plus y square, where a is the x-intercept and b is the y-intercept, minus ax minus by equal to 0. Sometimes, what is the equation of the circumcircle of the triangle formed by the line with the coordinate axis? The circumcircle of the triangle, formed by the line ax plus by plus c equal to 0 with the coordinate axis. If you want equation of this circle, what is the here given condition? We want to find the circumcircle of the triangle. What are the three sides of the triangle? One is ax plus by plus c equal to 0. Other two sides are the coordinate axis. That means we will get like this. This line equation is given, ax plus by plus c equal to 0. And remaining two sides are the coordinate axis. Coordinate axis means this is the right angle triangle. Our aim is find this circle equation, circumcircle of the triangle. So I will get this equation. Indirectly we can find this point. This is the x-axis, this is the y-axis means. What are the coordinates of this means? X-axis means y equal to 0. This is called x-intercept comma 0. X-intercept means y equal to 0. We will get minus c by a comma 0. This point is 0 comma y-intercept. Y-intercept is obtained by putting x value is 0 minus c by b. And this is 0 comma 0. Now what is the nature of the circle? The circle passing through 3 points, 0, 0, minus c by a 0, 0 comma minus c by b. These are 0, 0, a 0, 0 b form. In that case, what is the circle equation directly? X square plus y square minus ax, that means plus c by a into x plus c by b into y equal to 0. This is the circumcircle of the triangle formed by the line with the coordinate axis. And concentric circle, or if you want the equation of the circle, this is also one of the useful result. Equation of the circle passing through 0, 0, a comma b, 0, 0, a comma b, and the next point is b comma a. So what is the condition here? One is the origin. What is the second point? A comma b. Third point is b comma a. Actually, b comma a is the image of the point a comma b with respect to the line y is equal to x. So if the points are given like this, then directly circle equation x square plus y square by a square plus b square is equals to x plus y by a plus b. And remember as a formula. I will get the circle means again take the general circle and substituting one by one, we will get g value, f value, already c value is 0. So easily we can remember like this, x square plus y square by denominator a square plus b square is equal to x plus y by a plus b. And concentric circle. Concentric circles means two or more circles are said to be concentric means they have same center. Centers are same but radii is the different. So these are the concentric circles. That means if x square plus y square plus 2gx plus 2fy plus c equal to 0 is one circle, then this is the S. Its concentric circle is so center is same, means up to y terms both equations are same. Concentric circles are differ in constant term only. That's why how to take the concentric circle of this one, x square plus y square plus 2gx plus 2fy plus some constant k equal to 0. So if you want this equation, here one unknown is there, k is the unknown. For finding k value, some other condition is required. Suppose this circle equation is given, this is the given circle. Then what is its concentric circle? Means so many circles are there, infinitely many circles are obtained, concentric circles. But if you want concentric circle passing through the points on 1, 2, then this is one particular single circle. So what is the use of this point? For finding the k value, you can use that point. So first you can take the concentric circle like this, and substituting the 1, 2, we will get the k value. So whenever if you want concentric circle equation, concentric circles are differing constant term. So immediately you can change the constant as some k. For finding k value, some condition will be given. In numerical problems, you can do like that. Concentric circles means having the same centers but different radii. Next, concyclic points. Concyclic points means, so if 4 points lie on the same circle, then those points are called concyclic. If A, B, C, D lies on the same circle, then those are called concyclic points. And already in school level we know conditions. If A, B, C, D is the cyclic quadrilateral. Cyclic quadrilateral means those vertices lies on the circle. What is the condition? Sum of the opposite angles is 180 degrees. B plus D is 180, A plus C is 180. Here, how to prove that 4 points are concyclic? The process is, first you have to find the circle passing through 3 points. After getting the circle equation, we have to substituting the 4th point. If the 4th point satisfies the equation, then we can say that these points are concyclic. If 4th point does not satisfy the equation, means then non-concyclic points. Here some shortcuts are there. If the points mi, 1 by mi, where I is equals to 1, 2, 3, 4 are concyclic, then the condition is, if the points mi, actually it containing 4 points, I equal to 1, we will get 1 point, m1, 1 by m1, I equal to m2, 1 by m2, m3, 1 by m3, m4, 1 by m4. If these points are concyclic, then the condition is product of the x coordinates value is 1. Actually, what are the x coordinates? m1, m2, m3, m4. That means then condition m1, m2, m3, m4. This value is equals to 1. Very, very important, useful result. Product of the y coordinates also 1. How will get this result? So what is the given condition? The points, 4 points are concyclic. That means these 4 points lie on the same circle. Let us take the circle B. Let the circle be some for convenience we can take the standard form, x square plus y square equal to r square. So according to the data, these 4 points lies on this circle. Then substituting 4 points, but by observation all these 4 points are there in the form of m, 1 by m. So first we have to substituting m, 1 by m here. Then we will get m square plus 1 by m square is equal to r square. That means m power 4 minus r square m square plus 1 is equal to 0. We will get a 4th degree equation in terms of m. So it has 4 roots. What are the 4 roots? According to the data, what are the roots? m1, m2, m3, m4 are the roots. Now directly we can take the product of the roots. Already we know the relations between the roots and coefficients. Directly we can take the fourth relation. What is the fourth relation? Product of the all the roots m1, m2, m3, m4 is equal to constant term by leading term coefficient. It is a fourth degree equation, means alternate signs. For m cube term we can take minus m square plus m minus constant next plus 1 by 1. So this is 1. So this is the one of the statement. If the points mi comma 1 by mi are concyclic, then what is the condition? m1, m2, m3, m4 is equals to 1. Next, suppose if the lines a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0 meets the coordinate axis at 4 concyclic points. Then so here two lines meets the coordinate axis at 4 points. So these are the coordinate axis. Suppose this is one line. This line meets the x-axis at A and y-axis at B, and another line is given. This is another line. This line meets the x-axis at C, y-axis at D. What is the given condition? These points are concyclic. Concyclic means all these points lies on the same circle. Then what is the condition? That is very, very important. If these lines meets the coordinate axis in 4 concyclic points, then condition is a1 a2 is equals to b1 b2. Product of the x coefficients is equal to product of the y coefficients. And sometimes asking what is the circle passing through these points, and that circle direct formula is equation of the circle through those points is just you have to take the product of these two lines. The product of these two lines gives the second degree equation that represents a circle. a1x plus b1y plus c1 into a2x plus b2y plus c2 is equals to 0. But here important point is after taking the product we will get xy term also, but circle equation not containing the xy term. That's why you can remember this one. Drop xy terms. Whenever xy term is obtained, don't take that term. Remaining terms are the represents equation of the circle. So that what is the concept here? If two lines meets the coordinate axis at 4 concyclic points, then the condition is a1 a2 is equal to b1 b2, and the equation of the circle is obtained just taking the product of two lines. I will get this result. Actually, AB and CD are two lines. Its combined equation is, what is the combined equation of these two? Just take the product of these two lines. Like that, another lines are coordinate axis. What is the combined equation of these two? xy equal to 0. This is y equal to 0. This equation is x equal to 0. Then combined equation is xy equal to 0. So these are the point of intersection of first pair and the second pair. So any second degree curve passing through the point of intersection of first pair of the lines and second pair of the lines can be taken as s1 plus lambda s2 equal to 0. s1 plus lambda s2 equal to 0 represents which one? It represents any second degree curve passing through the point of intersection of the first pair of the lines and the second pair of the lines. What is the s1? Combined equation of the first pair. That means a1x plus b1y plus c1 into a2x plus b2y plus c2 plus lambda into s2 represents combined equation of the axis xy equal to 0. It represents any second degree equation. It represents pair of the lines or circle or parabola, whatever it may be. But our aim is find the circle equation. So whenever if you want circle equation, then immediately you can apply the conditions of the circle. What are the conditions? If it represents a circle, what are the conditions? One condition is coefficient of x square is equals to coefficient of y square. So by observation, what is the coefficient of x square? a1 a2. a1 a2 is equal to coefficient of y square is obtained by taking product of these two items, b1 b2. So that is the condition direct. And what is the one more condition? xy coefficient is 0. What is the xy coefficient? Coefficient of xy equal to 0. xy coefficient is a1 b2 plus a2 b1 plus lambda. So from this we will get lambda value. What is the lambda? Minus a1 b2 minus a2 b1. Then substituting here, we will get equation of the circle. Just we will get this form, product of these two, and dropping the xy term, because of when simplify this equation, xy terms are eliminated, so that we can remember these two conditions. Whenever two lines meets the coordinate axis in four concyclic points, then condition is a1 a2 is equal to b1 b2, and circle equation, circle passing through those concyclic points is product of these two lines and dropping the xy term. Next, intercept made by the circle on the coordinate axis. Intercept made by the circle on axis. So first we can find the x-intercept. Suppose the circle equation is x general form, we can take x square plus y square plus 2gx plus 2fy plus c equal to 0. Then what is the intercept made by the circle on x-axis means? So this length is called the intercept made by the circle on x-axis. Simply it is called the x-intercept of the circle. So what is the x-intercept of the circle? I will get this one. Actually, what is the equation of the x-axis? Y equal to 0. Suppose x-axis meets the circle at 2 points, say A and B. Then the length AB is called the x-intercept. So for finding AB, first of all we can assume that the circle meets the x-axis at some points x1 comma 0 and x2 comma 0. Now solving circle and x-axis is nothing but y equal to 0. So solving these two equations, what happened? Put y equal to 0, we'll get x square plus 2gx plus c equal to 0. Then substituting y equal to 0, we'll get one quadratic equation in x. So according to the data, it has two roots. What are those two roots represents? Those two roots represents x coordinates of these 2 points. Actually here 2 x values are obtained. Those x values represents x coordinates of a point and the b point. So what are the roots here? x1 comma x2 are roots. Then we have two relations, x1 plus x2, sum of the roots minus 2g, x1 x2, product of the roots is c by 1, that is c. Our aim is find the x-intercept. X-intercept of the circle is nothing but here AB value, distance between AB. What is the AB? According to this distance, we will get x1 minus x2 modulus. But we know x1 plus x2 and x1 x2, so we can write under root x1 plus x2 whole square minus 4x1 x2, that means under root 4g square minus 4c, so we will get 2 into root of g square minus c. So this is a formula for x-intercept of the circle. What is the x-intercept formula? 2 into root of g square minus c. Very very important form. So in JEE mains, so many times problems are given based on the x-intercept or y-intercept, or when the circle touches the x-axis, circle touches the y-axis. This concept is very important. Circle and coordinate axis relations when touching or intersect at 2 points like that. So that x-intercept is 2 into root of g square minus c. Similarly, y-intercept of this circle is 2 into root of s square minus c. So these are the two formulas, x-intercept and y-intercept. Now, if the circle touches the x-axis at some point a x1 comma 0, if the circle touches the x-axis, then we have to derive the conditions. This is x-axis. The circle touches the x-axis at the point x1 comma 0. Here some 0 comma 0 is there. What are the position of the y-axis? Then what are the conditions? These conditions are very important. When the circle touches the x-axis means this is the this is the center, it is the radius. If the radius is r, then y coordinate is also r. Y coordinate is nothing but height or distance from the x-axis. So this is also r. That means what is the one of the condition? Whenever the circle satisfying the condition, that is radius and y coordinates are same. Radius is nothing but y coordinate of the center. So radius is equal to y coordinate of the center. In that case, what is the nature of that circle? That circle touches the x-axis. Or one more condition, if the circle touches the x-axis means what is the x-intercept made by the circle? There is no intercept. Whenever x-intercept is obtained, when the circle cuts the x-axis at 2 points, then some length is there. Then the circle touches the x-axis, there is no x-intercept. That means x-intercept value is 0. So that x-intercept is 0 means this value is 0. Then what is the condition? G square equal to c. This is also one of the condition. When the circle touches the x-axis, then that must be satisfying this condition, g square equal to c. And one more, when the circle touches the x-axis, already when the circle cuts the x-axis at 2 points, say x1 comma 0, x2 comma 0, then in that case we will get one quadratic equation. What is that one? X square plus 2gx plus c equal to 0, and the roots of this equation are x1 and x2. That's why we get x square plus 2gx plus c is equals to x minus x1 into x minus x2. Because of x1, x2 are the roots, that's why this is exactly equivalent to product of the linear factors, x minus x1 into x minus x2. Whenever it happened, when the circle cuts the x-axis at 2 points, but here the circle touches the x-axis at the point, only one point. Touching means that meets the circle, that line, that circle touches the x-axis at only one point. In that case, what is the relation? This is a very important relation. In that case, x square plus 2gx plus c, what are the two roots of this equation? The two roots of this equation are equal roots because of touches case. Touches at only one point. That's why this quadratic equation roots are same. So this side what happened? We'll get x minus x1 into again x minus x1 whole square. So that when the circle touches the x-axis at the point x1 comma 0, then directly we'll get g value and c value by using this relation. Then expanding this and comparing the corresponding coefficients, we'll get g value and c value. Whenever if you want to find the circle equation, what are required? G, F, C. So when circle touches the x-axis at some x1 comma 0, directly we will get the g value and c value from this relation. And f value is obtained from some other condition will be required. In the problems, that condition will be given. So we can remember these three conditions. Whenever the circle touches the x-axis, radius is nothing but y coordinate of the center, or and g square equal to c because of this length is 0, Or one more relation, x square plus 2gx plus c. X-axis means y equal to 0. We will get this quadratic expression, that is same as x minus x1 whole square. Similarly, if the circle touches the y-axis, then what are the relations? The radius is nothing but x-coordinate of the center. When the circle touches the y-axis at some point, let us take 0, y1, what happened? This is the radius, at the same time this is the x-coordinate of the center. That's why radius is equal to x-coordinate of the center, or y-intercept value is 0. So f square equal to c, or when touches the y-axis means put x value is 0 in the circle, we will get y square plus 2fy plus c is same as y minus y1 whole square. So you can remember these three conditions. Whenever the circle touches the y-axis, these are very useful concepts. In sometimes we can solve the problems by verifying the conditions only. No need to find the complete solution. Just by verification we will get answer also. So if you are perfect in the concepts, then without solving the problem directly we can tick the answers. So touches the y-axis, r equal to cx, or f square equal to c, or like this. Suppose when the circle touches the both the axis, circle touches both the axis, suppose if the circle touches the both the axis and having the radius is r, in that case 4 circles are possible. One is circle touches positive x-axis and the positive y-axis, or circle touches negative x-axis and the positive y-axis, here. So 4 circles are obtained. So that means if we know radius of the circle, suppose the radius of the circle is r, and the circle lies in the first quadrant, then what is the equation? What is the center? What is the concept? Whenever the circle touches the x-axis, y coordinate is same as the radius. Touches the y-axis, x coordinate is same as radius. So here x coordinate to y coordinate both are equal to r. Here what is the center? Minus r comma r. Because of the position of the circle is lies in the second quadrant. That's why we can take center as minus r comma r. Here center is minus r comma minus r. Here center is r comma minus r. So that particularly sometimes asking like that, the circle touching the coordinate axis and having the radius 5 units and lies in the third quadrant. In that case we can take center as minus r comma minus r, and the radius is r. After that we can find the circle equation. So whenever the circle touches the coordinate axis means how many circles are possible? 4 circles are possible. One is lies in the first quadrant, second, third and fourth. When joining all these centers, we will get one diagram, that is the square. Sometimes asking what is the area of this square, then distance between these two becomes the side length of this side. After that side square is the area, or sometimes asking the perimeter, or sometimes asking what is the circle, what is the radius of the circle, what is the minimum circle which touches the given 4 circles. So here 2 circles are possible. One circle touches these 4 circles like this. This touch is called the external touch. This circle touches 4 circles externally. One more circle also possible here also. This is also circle which touches the given circles internally. For this circle the radius is maximum. For this circle the radius is minimum. Sometimes asking what is the equation of the circle having the minimum radius, or what is the minimum radius value. So I will get minimum radius. For this circle, what is the center? Center is the midpoint of the diagonal, that is 0, 0. And what is the radius? If you want radius of the circle, let us take that is capital R. Then this is also capital R. This is small r. This is a small r. Now I will get our aim is find the capital R value. So what is the relation? length of the diagonal is equal to r plus 2 capital R. What is the distance between these 2 points? R plus r whole square, 4r square plus 4r square. This is equals to r plus r, 2r plus 2 capital R. We want to find the capital R value. So this is 2 root 2 r is equals to 2 times small r plus capital R. 2 gets cancelled. What is the capital R value? Root 2 minus 1 into r. So directly you can remember as a formula, the circle having the minimum radius and touches the given circle C is, what is that radius? Root 2 minus 1 into r. Center is 0, 0. If you want the radius of this circle, radius of the big circle, this is the small circle radius. Big radius circle radius is a big circle is root 2 plus 1 into r. This total gives the diameter. After that we can find the radius. This is the radius of the big circle. This is the radius of the small circle. So that we can remember all these points. So next, maximum and minimum distance of the circle from the point. Suppose it is a circle. Some point P lies outside of the circle. Then what is the minimum distance from point to the circle means? We can measure the distance from P to the this end of the diameter. The maximum and minimum distance always lies along the normal. This diameter is the normal of the circle. So we can measure the distance from P to this end. Then it represents minimum distance of the circle from the point P. Maximum distance means we can measure the distance from P to the other end of the diameter. So like this. So when the point lies outside, what is the minimum distance? Minimum distance is equals to PA. What is that value? I will get that value in terms of known. In the problems, circle equation will be given. So in terms of known data, what is that value? Minimum distance CP minus R. When the point lies outside, what is the minimum distance? CP minus R gives the PA. And the maximum distance is nothing but PB. We can measure the distance from P to the other end of the diameter. But we don't know these points. We know circle and this point. Then what is the minimum distance means? CP minus R. This is the R. This is also R. What is the maximum distance? CP plus R. CP plus R. Sometimes asking sum of the these two distance, maximum and minimum distances, we will get to 2CP. So this is the these are the conditions when the point lies outside. When the point lies inside, what happened? Suppose it is the center. Suppose point lies here. Then this is the diameter. Through P, always we can draw the diameter. Then this length is the minimum distance. And this is the maximum distance. Here what is the minimum distance? P lies inside. Here P lies outside. If the point P lies inside, what is the distance? Here R minus CP is the minimum distance. So minimum distance is equals to R minus CP. And the maximum distance is equals to, maximum distance of that point is PB, that is R plus R. What is the maximum distance from P to this one? So CP plus R. In this case, what is the sum of the distances? We will get to 2R. Sum of the distance is 2R. But here sum of the distance is 2CP. So whenever if you want to find the maximum and minimum distances, compulsory you have to check the position of the point. Again, how to find the position of the point? If P lies outside, P point lies outside of the circle, already we know condition. Outside, what is the condition? S11 is greater than 0. P lies inside of the circle, S11 is less than 0. P lies on the circle, S11 is equals to 0. These are the conditions. These are the conditions for position of the point with respect to the circle. Lies outside, S11 is greater than 0. Lies inside, S11 is less than 0. And lies on the circle, S11 is equal to 0. And here one more concept is sometimes asking the point A. Actually, what is the point A? That is a point on the circle which is minimum distance from the point P. Then I will get A coordinates. If you want A point, what is the method? Here we know P point and center. Now, if you want the point which is lies on the circle and their minimum distance from the point P means clearly A divides CP in some ratio. These 3 points are always collinear. A divides CP in what ratio? What is this length? This length can be taken as CP minus R. CP minus R, this is R. That's why A divides PC in the ratio CP minus R is to R internally. By using internal division formula, we will get A point. Suppose if you want B point, then B divides CP in what ratio? CP in what ratio means CB is to CB. CB is CP plus R, CP and R. External division. So based on the ratios, we can find that one. Or if you want other end of this diameter, I will get this point. Let us take C divides PB in what ratio? C divides PB in what ratio? This is CP is to R internally. Let us assume that this point is some alpha beta. First we have to find the C coordinates by using P and D. After getting the point, comparing it to the center, then we will get alpha and the beta values. In both cases, we can use the internal division best. If you want A point, okay, directly A divides internally. But here B divides CP externally. Or if you want to use the internal division formula only, first you can find the C point and comparing the corresponding coordinates, we will get B alpha comma beta. This is also important. So the points lies on the circle which are minimum and maximum distance from the point P means we can use the division formulas. Similarly, what is the minimum distance from a circle, line to the circle? Here also same concept. Suppose line is there. This is the minimum distance. This length is the minimum. Then I will get this length. So total is a perpendicular distance from center to the line. That means D. Let us take total distance is D. That is nothing but perpendicular distance from center to the line minus radius. It represents minimum distance of the line from the circle. What is the maximum distance from the line to the circle means we can measure distance from this point to other end of the diameter. What is that one? This is the D plus R. What is the D represents here? That is the perpendicular distance from C to the given line. So these are the distances, minimum and maximum distances from the line and the circle. And line and circle combination, line and circle. So when one line and circle are given, 3 cases are arise. The line cuts the circle, or the line touches the circle, or the line neither touch nor intersect the circle. So similar concepts are there in the remaining chapters also, parabola, ellipse, hyperbola, like that. But in the case of circles chapter, conditions are very simple, because center is say C. Always you can take D as the perpendicular distance from center to the D. Then when the circle cuts the circle when the line cuts the circle at 2 points, what is the relation between the radius and perpendicular distance? D is R is your R value is greater than D. When R is greater than D, the line cuts the circle at 2 points. Here the radius and perpendicular distance are same, r is equal to d. When the line is tangent, touches means tangent to the circle, it is very important condition, r is equals to d. When the line is neither touch nor intersect, condition is radius is less than perpendicular distance from center to the line. So these are very important conditions. Sometimes line and circle are given. If the line cuts the circle at 2 points, then what is the unknown in the line? How to find the unknown in the line means we can use this condition. Or sometimes the question will be given like this: 2x plus y plus k equal to 0, and this is some circle, x square plus y square equal to 8. If this line cuts the circle at 2 points, what is the range of k? I will get range by applying this condition. R is greater than D, we will get a range of that one. In this case, we will get some k values. Here we will get so many values for k. Here we will get only touches case means equality is there. That's why you will get 1 or 2 values. R is equal to D. Perpendicular distance equal to radius. So this is also one of the important concept. Next, if from external point, actually, or you can do first. Suppose P is one external point. If you draw the tangent from the point P, it meets the circle at some point T. Then this PT is called the length of the tangent. PT is called the length of the tangent. So the length of the tangent formula is root S11. Length of the tangent is always, I will get this length, let us take center, this is the radius, this is the CP value. So this is the perpendicular. Radius line is always perpendicular to the tangent. So from this, PT square plus R square is equals to CP square. From the Pythagoras theorem, we will get this one. So PT square is equal to CP square minus R square. CP is the distance between center and P. CP square minus R square is always gives S1. Then from this PT value, root S1. CP square minus R square, this is some real number. This real number is called power of the point. So one point and circle are given. What is the power of the point means CP square minus R square, or simply that value is S1. Power of the point formula is S1. Length of the tangent formula is root S1. Power of the point will be either positive, sometimes we will get positive, sometimes negative, sometimes 0 also. Whenever the power of the point is positive, when the point lies outside, then the power of the point is positive, because S11 is positive, that's why power of the point is positive. When the point lies inside, the power of the point is negative. When the point lies on the circle, power of the point value is 0. What is the definition of the power of the point? Cp square minus R square is called the power of the point. It is the length of the tangent. And the equation of the tangent at the point. Suppose Px1, y1 is the point on the circle. Then what is the equation of the tangent to the circle? Circle equation x square plus y square plus 2gx plus 2fy plus c equal to 0. Then equation of the tangent is s1 equal to 0. What is the notation for s1? In the place of x square, we can write xx1. Whenever square term is there, we can take xx1. Y square becomes yy1 plus 2gx becomes half of this coefficient g into x plus x1 plus f into y plus y1 plus c equal to 0. This is the equation of the tangent to the circle. We can remember as a formula. Otherwise, we can use the calculus method. That is a lengthy process. Better to, whenever second degree equation will be given, the equation, not only circle equation, whatever it may be, second degree equation, if you want tangent at the point, then at the point means that point lies on the circle, lies on the curve. In that case, what is the formula for tangent equation? S1 equal to 0. I will get S1. X, in the place of x square, we can write x x1. In the place of y square, y y1. Whenever x term is there, g of x plus x1, y term is there, f of y plus y1, constant asterisk. Sometimes if the second degree equation containing xy also, in that case 2hxy term is there, suppose. In that case, what is S1 for this? Half of the xy coefficient, that means h into xy1 plus yx1. X square is x square becomes xx1, y square becomes yy1, 2gx becomes g of x plus x1, this is f of y plus y1. Suppose 2hxy term, in the case of this one, h into xy1 plus yx1 plus it. But here no need to take the xy term, because of this is a circle not containing the xy term. So this is the formula for tangent at the point. Sometimes find the equation of the tangent drawn from the point. Both are different. If you want equation of the tangent drawn from the point px1 comma y1 to the circle, in that case I will get circle equation. Already along the tangent we know point. Then what is required for finding this equation? Slope. That slope is say m. Then what is the equation of the tangent now? Y minus y1 is equal to m into x minus x1. So it containing one unknown. What is that one? M. I will get m value. This line is tangent to the circle. That's why applying the condition r equal to d, we will get m value. So that no need to do like this. Direct formula is there. The tangent drawn from the point having the slope m, in that case that tangent equation is y plus f is equal to m into x plus g plus or minus r into root of 1 plus n square. So whenever if you want to find the equation of the tangent drawn from the point, we can use this formula. Here g, f, r values are obtained from the circle equation, and passing through the point means substituting x1 y1, then we will get one relation in terms of m. Quadratic equation is obtained. After that, solving that quadratic equation, we will get m values. After getting the slope, substituting here, then tangent drawn from the point is obtained. So tangent at the point, tangent drawn from the point, both are different. At the point means the point lies on the curve also. From the point means this point lies outside of the curve. Actually it gives two tangents, because of from external point two tangents are exist. That's why it represents two tangents equations. This is a very useful formula. Suppose if the center of the circle is 0, 0 and radius is r, for this this is called equation of the tangent in slope form. Whenever if you know slope of the tangent, we can use this formula. When the center is at 0, 0, what is the circle equation? X square plus y square equal to r square. For this circle, what is the tangent equation in slope form means? Here gf values are zeros, so we'll get y is equal to mx plus or minus r into root of 1 plus n square. Y is equal to mx plus or minus r into root of 1 plus n square. For a standard form, this is the formula for general circle. Center at minus g comma minus z. In this case, this is. So here we can use this formula in so many cases. Suppose if tangent makes an angle 30 degrees with the x-axis, then what is the equation of the tangent means? We can use this formula direct. Because of slope, you know, inclination is 30 means tan 30 is the slope. Whenever if you know slope, directly substituting, we will get that equation. So this is called the equation of the tangent in slope form. This is the second form of the tangent. One is tangent at the point, other one is tangent drawn from the point. And one more form is there, that is the parametric form. If you know parametric coordinates, suppose what are the parametric coordinates of this circle? Suppose 0, 0 is the center and r is the radius. Then what is meant by parametric form of the circle means that represents any moving point along the circle. Suppose px comma y is the any one of the moving point along the circle, which makes an angle theta. This CP line makes an angle theta with the x-axis. Then draw the perpendiculars. Then what is the, this is the x, this is y, this is the radius say r. Then what is the x value? X is equal to r cos theta, y is equal to r sin theta. So these two equations together represents a circle. What is the nature of that circle? That is whose center is 0, 0 and the radius is r. This form of the circle is called the parametric form of the circle, where theta is called the parameter. Why you can say that it is a parameter? Here theta is not fixed. Theta is the angle depending upon the point. When the point is there, here angle is theta. When point is moving like this, theta will be different. So the value of theta is depending upon the point x comma y. That's why theta is not the fixed constant. That is some parameter. That is depending upon some other quantity. So that's why this theta is called the parameter. Suppose what are the parametric coordinates of the circle having the center at h comma k and radius is r. X is equal to h plus r cos theta and y is equal to k plus r sin theta. And center is h comma k. Suppose in the case of general form, x is equal to minus g plus r cos theta and y is equal to minus f plus r sin theta. So center h comma k, center minus e comma f. Here center is 0, 0 and radius is r. These are the parametric form of the circle. So sometimes for solving the problems, if you want any point on the circle, we can take the parametric form. Any point, some r cos theta comma r sin theta, when the center is at the origin. So what is the equation of the tangent to the circle at the point P of theta? P of theta is nothing but we can take the coordinates in terms of the parameter r cos theta comma r sin theta. The center is 0, 0. Then the circle equation is x square plus y square equal to r square. For this circle, what is the tangent? Generally x1 plus y1 minus r square equal to 0. Where x1 is r cos theta, x r cos theta plus y into r sin theta minus r square equal to 0. So x cos theta plus y sin theta minus r equal to 0. This is the parametric form of the circle having the center at 0, 0. Center not at 0, 0, then the tangent equation is x plus g into cos theta plus y plus f into sin theta minus r is equal to 0. So you can observe the difference. Here center is at 0, 0. In that case tangent equation. This is center at minus z comma minus f. Actually this is obtained by using the translation of axis. Origin be shifted to the point minus z comma minus f, we will get this formula. So that this is also one of the formula when if you know angle, parametric angle. That means point is given in terms of theta. So again so many concepts are there. I will make one more video for other concepts.